Okay, I found this one to be a bit more intuitive. I instantly, when I saw this here, and I won't be using my pen, but I will be using Microsoft Equation Editor. So I'll be doing a lot of copy and pasting. So I found this to be a bit more intuitive when I first looked at it, simply because the cosine theta minus one sort of remind me of what you would see sometimes, like square root x minus one over x, and you would know to multiply by the reciprocal. So that's what I did instinctively, and it was the right path to take. So and the teacher did this in class, so everyone will recognize this. So it's cosine theta plus 1, right? That's the reciprocal. So let's put that on the top and bottom. So there we go. And now, when you multiply this, of course, what are you going to get? So let's look at this. So we're going to FOIL it. So this, multiply that. And of course, at this level of mathematics, you should already know what the result's going to be. Going to have a cosine squared theta plus cosine theta minus cosine theta. I'm just doing this as an example. I'm going to erase this. Plus 1 squared. So you should already know this, and you should know that these two here, as positive cosine theta and negative cosine, they cancel out. So let's move forward with what we know. So let's edit this and add what we know is the answer. So it's going to be cosine squared, right? Theta minus 1 squared, which we don't even have to put the square, just minus 1. And this denominator remains the same. Well, at least with a theta on the outside, right? So, because this theta over here multiplied this cosine plus 1. So let me put this in parentheses. Okay. So, since we should be cool so far, I'm not doing anything too complicated. So now, what's the next step? Well, from here, we should recall that cosine squared minus 1, what that actually is. And let me start a new little thing here. So, just playing around with the numbers a bit. So cosine, what do we remember this? Here, I have to do this in order to memorize this little property. Cosine squared theta times sine squared theta. You should recognize this, right? Equals 1. Correct? So what happens if we, for example, take this 1 and move it to the other side? Well, basically, we have, for simplicity's sake, just the other side of the equal sign. So it's cosine squared theta plus sine theta, sine squared theta, minus 1 is equal to 0, right? And we could take this sine squared theta to the other side, so we'd have cosine squared minus 1 is equal to negative sine of theta squared. Alright, so I hope you kept up, and this should be really easy if you took the trigonometry. So basically, we know what we can now make our top here, and it's going to look quite familiar. So now we're going to our next step. So this, and keep in mind, let me go all the way to the left over here. The proper notation is to keep this limit always after the limit always on here, or else it'll be incorrect. My peers will know exactly what I'm talking about. So let's take this now, copy paste it. So now this is going to become negative sine of theta squared, right? That's what we found, that it was equal to. And it looks like we have to start a new line. Okay, so let's go ahead and do that. Edit object. So let's go all the way to the beginning. My computer's not that good, or this program's not that good. So we can split this up, right? And split it up into a couple products. So let me have this and start a little parentheses. So we can take the negative 1 out, right? Multiply it by, and let's bring what can we have? We can have what's sine of theta squared equal to? It's equal to sine of theta times, can you guess? Sine of theta, of course. So that's what we're going to do. We're going to split it up into a fraction by itself. So let's stick it in here now. So we're going to have sine of theta over, and we're going to stick theta in the denominator here. So basically we took the theta that's here and we just put it into this fraction, and now we're going to multiply that by what's left, which would be another sine of theta, right? Because we just split it up. Sine of theta over, and this is going to be cosine of theta plus 1. So I'm not going to put too much work into this because we already did this in class for any viewer, but I mean, you should understand exactly what I did. I basically split this negative sign from negative 1 times sine of theta over theta, and sine of theta over cosine of theta plus 1. So what do we have here? Well, basically we have everything we need, right? What do we find sine of theta? And remember, we're finding a limit as theta approaches 0. Let's distribute the limit. So let's go ahead and distribute this. Maximize, scroll up. So let me take this outside of the parentheses. And we're going to take this limit and distribute it using a product rule, and we can only do that, remember, with finite numbers. If this was theta to infinity, it would be a different story. So now, what is the limit as theta goes to 0 of this number negative 1? Well, theta is not even a factor, so we know that that limit is just going to simply be negative 1. So let's bring that up. This is just going to be negative 1, right? And what did we find earlier? The limit as sine of theta, if you saw my last video, the limit of sine of theta over theta, and we used a visual method of calculating it, and we discovered that through the squeeze theorem that when theta approaches 0, this limit is equal to 1. So maybe the only thing that might be new, that we have to use any logic at all, is this equation here. So we can apply this limit on both the numerator and the denominator, right? Put the parentheses just to follow the proper notation, if anything. And now, what's the limit as theta approaches 0 of sine theta? Well, let me edit this object again. It'll be 1, right? Well, I'm sorry. When sine of 0, we can just plug this in, right? So sine of 0, and we know if we just imagine, I personally imagine just looking at a sine chart for a second. So let me just bring this up. So I just imagine sine, and I know the graph goes something like this, right? And at this point right here, we have 0, 0. So when x is 0, alright, y is equal